Hi there. We looked today in class at a review of chain rule as well as an extension of chain rule. So we did 4 example problems today, and then we'll do 4 more the next time you're in class. We did examples 1, 3, 5, and 7 on the worksheet that I've uploaded to my website. My recommendation would be to print it off and then to start with doing numbers 1 and number 3 to the best of your ability on your own, and then restarting this video. That way you can check your work and you can get unstuck if you do in fact get stuck. The reason I'd recommend doing that is example 1 and 3 you've already learned how to do. We practiced them last semester. I know it's just been a little while. So yeah, that's what I would recommend for 1 and 3. When you get to 5 and 7 then, this would be my recommendation. Number 5, kind of follow through with me as I demonstrate it, as I explain it. Then pause the video. Try number 7, which is very similar, on your own. Restart the video and check your work or get unstuck if you did in fact get stuck. Okay, so again, 1, 3, try on your own, then watch. 5, watch the video, walk through with me. 7, pause the video, try it on your own, and then start the video again. Okay? So here we go. Go ahead and pause the video if you're planning to do number 1 on your own. I'm going to start walking through it. Start the video again when you're ready. Okay? Example 1. We have y equals cosecant squared x. To take its derivative, we need to rewrite this. The reason we rewrite it is we know this is chain rule. The reason we know it's chain rule is because there's something in my trig. The only derivatives that we know, that we have rules for, I should say, are singular trigs with singular variables. If there's anything attached to the trig or anything attached to the variable, that's our cue, it's chain rule. And we rewrite it with parentheses so we can see the 2 functions of our chain rule, the composite function, right? Because this squared is attached to the cosecant, when I rewrite this, I'm going to rewrite the cosecant x in parentheses with the squared on the outside. The squared is attached to the cosecant, meaning the whole function, right? And so the squared goes on the outside. Taking the derivative then, we take the derivative of the outside. Our outside function in this case is the squared, so we're going to bring down that 2. But make sure you leave those guts alone. Leave that cosecant x as it is, and then subtract 1 from the from the exponent, sorry. Then, once you've finished that outside derivative, now you can take the derivative of the guts. The derivative of the guts, in this case, the derivative of cosecant x, is negative cosecant x cotangent x. Okay, and so rewriting this, we get negative 2 cosecant squared x cotangent x. Okay, next up, number 3. Number 3, again, we know is chain rule for this second piece because there's something in there, right? It's not a singular trig with a singular variable. There's something in my trig. Okay, in this case, this squared is attached to the x, not to the secant, right? This is different than number 1 where the exponent was attached to the trig function. Now the exponent is attached to the x, which means that my parentheses for this one go around the x because those are my guts. That's my composite function, or the inside of my composite function. Okay, and then we have 7x squared times secant x squared, which is going to be product rule, 1d2 plus 2d1. Okay, so we've got our 1, which is 7x squared. d2, we're going to do derivative of the outside first. The derivative of secant is secant tangent. And then make sure that we leave our guts alone. So this is going to be secant x squared, tangent x squared. Right, that's our outside derivative of our d2. Then we could do times the derivative of the guts. Plus my 2, secant x squared, d1, derivative of 7x squared, is 14x. We do need to factor in this case, but so we can see our factor, I'm going to start with just rewriting this. So all I did was combine things here, right? 7x squared times 2x is 14x cubed. Everything else, I brought this 14x to the front, right? So just rewrote it. That allows us to see our factors, right? There's a common factor of 14x and a common of secant x squared. And so I'm going to pull that out. And there's my answer. Okay, number 5 and number 7. These are a little bit more of an extension chain rule. The reason why is that you actually have 2 chain rule pieces, right? In this case, we have 2 issues with this cosecant squared 3x that we're asked to take the derivative of. The first one is the 3, right? We know derivatives of singular trigs with singular variables. 3 is in there with that variable, and so that's one issue. There's one chain rule piece. The other issue is the exponent, right? This means that this is not a singular trig, right? And we have to have a singular trig with a singular variable. And so this is another issue, another chain rule piece. Okay, in terms of taking the derivative, we're going to start with rewriting, just like we always have. Let's rewrite this squared. Because the squared is attached to the cosecant, it's going to mean it's going to come on all the way on the outside, that the cosecant 3x is going to be inside those parentheses. And when you do that, you can now see the 3 layers, right? We have our outside function, which is the squared, and if I pull away that, now that once I take the derivative of it, then I'll be left with the cosecant. That'll be a middle function. And then I can pull that away, and I'll be left with just the 3x, which is the small function. Right, 3 types, or 3 levels. Okay? We're going to start with the outside, just like we always have. Our outside in this case is that squared. So we're going to pull that 2 down. Make sure to leave the guts alone, just like we always have. Subtract 1 from the exponent. Okay? Then we're going to take the derivative of the next one. So we've taken the derivative of this squared, so we're going to peel that away. The middle one is the cosecant. Right? So we're going to take the derivative of cosecant, which is negative cosecant cotangent. And then make sure to leave those guts alone. This will be negative cosecant 3x cotangent 3x. Now you could take the derivative of the smallest function, which is the 3x, because you've taken care of the squared here, you peel that away, take care of the cosecant next, peel that away. Now you have the 3x. Derivative of 3x is 3. And then again, rewriting, we have 2 times negative times 3, which is negative 6. You have 2 cosecant 3x's. This is cosecant squared 3x. And then the 1 cotangent 3x. There's your answer. Okay, try number 7 on your own, then restart it. Here we go. Number 7, we have dy dx equals, and then if I rewrote this, this would be tangent of x cubed minus 5 squared, because the squared is attached to the tangent, so it comes all the way to the outside. Okay, so outside dol first, let's take care of this squared. We're going to bring down that 2, leave the guts alone, and subtract 1 from the exponent. Then you can peel away that square. Now you can deal with the tangent, which is secant squared. Leave the guts alone. And now you can peel away the tangent, and you can deal with this x cubed minus 5, which that derivative is 3x squared. And then again, when you rewrite it, 2 times 3x squared is 6x squared. Your tangent x cubed minus 5 and 2 secant x cubes minus 5s. And there you go.